Hello everybody, I'm going to talk you through paper chromatography of plant pigments. So to get the pigments out, first of all you have to take some leaves and then you put them into a mortar and pestle with some sand, and then you bash them all up in the mortar and pestle in some solvent. The pigments will dissolve in the solvent, and once you have that mixture, you then pour it through a filter, and the pigments then should be in the fluid the fluid that comes through the filter paper. So after you've got your solvent, which is full, hopefully, of plant pigments, you have to prepare your chromatogram. So how do you do that? So you take your chromatography paper and you cut it to fit the chromatography tank. We actually used boiling tubes, but you can use coffee jars. So if you look at this setup here, you can see that the chromatography paper has been cut to fit the tank. You then draw a line in pencil. Now this is before you put it into the tank. You draw a line in pencil 2 centimeters from the bottom of the paper. Remember, it should be in pencil because pencil will not move with the solvent. And then using a micro pipette, that's a tiny little capillary tube, you add pigment to the origin spot that you have marked with pencil. And again, this isn't yet in the chromatography jar. So you would add a spot, you would let it dry, you add a spot, you let it dry. You do that at least 6 times until you have a lovely concentrated spot of plant pigment. So the paper then would be prepared, it's sitting on your desk, and then you add solvent to the tank and you put the lid on, and that allows the air inside the tank to become saturated with solvent before you actually add the chromatogram to the tank. So the next thing you do then is you need to run the chromatogram. So once the air is saturated with solvent, you then put in the chromatography paper. Remember that the solvent should be below the baseline or the origin on which you have that concentrated spot of plant pigments. So you suspend the chromatogram in the solvent, the pencil line must be above the solvent, and the chromatogram must not be at an angle. That's really important because if you were running a few spots, that would mean that some would get solvent more quickly than the other. And you let it run and you stop the whole process whenever the solvent is very near the top. So maybe the solvent which was here, it is absorbed up through the paper, and if it gets to here, I would just stop it there. Now it's really important that you mark where the solvent has got to. So we say that you mark the solvent front before it dries, because if it dries you won't be able to see where it got to. So you can mark it just with pencil or with a pair of scissors, just nick a little bit out of the side of the paper. Now there are some things to note. Some of the plant pigments will be more soluble than others, and they are going to travel further through the chromatography paper. This isn't like chromatography of amino acids because the plant pigments are all visible, and so you don't need to spray it with ninhydrin to make them become visible. So this is what you would expect. So here you can see that the solvent front has been drawn in with pencil. There you have the origin line, and this is what you expect. Chlorophyll B, which is green in colour, it usually just is above the origin line. Chlorophyll A, which is blue-green in colour, it goes a little bit further. Another plant pigment, which is called xanthophyll, it is yellow-brown and it is further up the paper. And at the top here you have carotene, which is yellow. I seem to remember you got most of those, which is good. So you then, using that picture I just showed you, you have to use it to calculate the RF values of the mysterious plant pigments. So an RF value, remember, it's always less than 1. So if you get a value that is greater than 1, you've done it wrong. So to work out the RF value, it's the distance that the pigment has moved, and that is divided by the distance moved by the solvent. So just make sure you understand what that is. So if we go back to this, it is the distance moved by the pigment So that would be the distance from here, and if we're doing carotene, to the middle of this spot, divided by the distance moved by the solvent, which we record as the distance between the origin or the baseline and your solvent front. So it's a small number divided by a large number, and that gives us an RF value. We can then look up tables and we can then identify the spots. Now, in some of the papers, they talk about controlled variables when it comes to chromatography. So every time you complete chromatography with plant pigments, if you're comparing plant pigments, what should you do? What should be controlled? Every time you need to keep the type of chromatography paper the same. Some paper is thicker than other chromatography paper, but you must, every time you do it, keep the type of chromatography paper the same. You must keep the solvent the same and the concentration of solvent the same, and you must keep the mass of the leaf that is ground up in that solvent the same. So those are controlled variables. And another controlled variable obviously is that whenever you're putting the spots onto the origin there, that you have the same number of spots every time you do this experiment. Now, what I would like you to do is find your past paper questions from A23 that are anything to do with plant pigments and see if you can answer them, and you should have your mark schemes to help with that as well.